Please enjoy the Insane Curiosity Channel's video about Earth's second Trojan asteroid recently discovered. Enjoy, you guys.
Recent studies suggest that the Jupiter Trojans resemble comets or Kuiper Belt objects when it comes to their composition, mainly water ice with a layer of dust. However, observations continue. So what was Tony Dunn's discovery, and why was it so important? Early Trojans are hard to find because during most of their orbits, they appear close to the sun in the sky. Not only that, but the gravitational resonance does not hold them in lockstep at 60 degrees ahead and behind of the Earth, explains Dunn. Instead, the objects trace paths around the L4 and L5 points, which are themselves moving as Earth orbits the sun. 2020 XL5 is almost certainly a garden variety bit of rock that went close to Venus and got perturbed into an orbit with a period very close to 1 year, says Bill Gray of Project Pluto. Aldo Vitagliano, a retired Italian chemist, said that the orbit should remain stable for 2,000 to 4,000 years, but gravitational tugs would eventually move it into another orbit. So far, 2020 XL5 has only been observed for only a few weeks, and amateur astronomer Sam Dean says we may have to wait until more observations can be made to pin down its orbit. As you can see in the simulation, it even almost reaches the orbit of Mars. And in that sense, it's actually a really interesting object, because first of all this means that eventually Mars will destabilize this orbit, and so the object will probably move away, possibly escaping somewhere else, or even becoming a Trojan of Mars. The existence of Trojan asteroids at the Lagrange points and some other planets can be seen as proof that such gravitational points exist. The existence of these points allows humans to place satellites and telescopes at Lagrange points, allowing them to stay in the same position relative to the Earth, while not using any fuel to hold themselves in place. This is wonderful, and that's why we call the Lagrange points parking places of our solar system. What about the first Earth Trojan? When was it discovered? The first Earth Trojan, dubbed 2010 TK7 because it was discovered in 2010, comes within 20 million kilometers, 12 million miles to Earth every few hundred years. It is currently drifting away. Models show its orbit is stable enough to stay in a 1-to-1 resonance with Earth for about 250,000 years. Does every planet have its own Trojans? The answer is probably yes, but in order to say why, we have to explain what a Lagrangian point is. In fact, as we said, Trojans are asteroids gravitationally locked to stable Lagrange points L4 or L5. Lagrange points are positions in space where the gravitational forces of a general two-body system like the Sun and the Earth, but they could be the Sun and Jupiter or the Sun and Mercury, produce enhanced regions of attraction and repulsion. These can also be used by spacecraft to reduce fuel consumption needed to remain in position. Lagrange points are named in honor of Italian-French mathematician Joseph Louis Lagrange. There are 5 special points where small mass can orbit in a constant pattern with 2 larger masses. The Lagrange points are positions where the gravitational pull of 2 large masses precisely equals the centrifugal force required for a small object to move within them. This mathematical problem, known as the general three-body problem, was considered by Lagrange in his prize-winning paper, Essai sur le problème des trois corps, 1772. We could say that in the circular, restricted three-body problem, there are a set of 5 points that if we place our spacecraft there, it'll never move relative to the 2 bodies. These are the Lagrange points. But whenever we find an equilibrium point in a dynamic system, the first question should always be, is it stable? Of the 5 Lagrange points, 3 are unstable and 2 are stable. The unstable Lagrange points labeled L1, L2, and L3 lie along the line connecting the 2 large masses. In plain English, unstable means that if we place any objects close, but not perfectly at one of these Lagrange points, the object will move away from the Lagrange point. The stable Lagrange points, labeled L4 and L5, form the apex of 2 equilateral triangles that have large masses at their vertices. L4 leads to the orbit of Earth and L5 follows. So every planet has its own L points, which means every planet could potentially have its own Trojan.
Unless my day turns upside down, I'll see you guys tomorrow live around 12 or 1 p.m. You guys have a great day. Bye-bye.